welcome everybody. This talk is hands-on learning through the lens of a laser engraver build because I thought building a laser engraver without following a plan was a very good idea. We'll get into that. My name is Pippa Hillebrand. By workday, I am a senior back-end software engineer, which means very little for this talk because actually I am a consummate DIYer, a person of many hobbies, and slightly crazy, which we'll get into. So, our agenda, very briefly, is we're going to talk about where I got the idea, why I got the idea, my attempt at planning. We're going to get into a prototyping and debugging loop, and then we will eventually escape the loop. And if we're very lucky and the demo gods smile on us, we will have the machine move. I have taken the decision to not have the laser module plugged in, mostly because I think Candace might be very sad if I set off the smoke alarm. And I have received threats. So, concepts. The spark of the idea. Why? Quite honestly. This conference. That's why. Last year at this time, I was having some really nice conversations about teaching kids how to code. And for many of us, our introduction to coding, well, this might be showing my age, was Logo, this silly little triangle that ran around on a computer and drew pictures. But it's a modern day and age. And you know what does the exact same thing as that silly little triangle? A laser engraver. Only it involves lasers and smoke and permanent tactile things that you can take with you when it's done. So with that, and it says 3D printers there as well, because it turns out that those also do the same thing. An FDM printer is a little thing that runs around spewing out plastic in a pattern, and then it goes up a level and does it again and again and again. It's that same concept. So when I was, between the ages of 6 and 13, I would have thought that having a thing where I could do a little bit of code and then it got laser burned into a little piece of wood was really awesome. It turns out I still think that. But how do we do it? And you'll see that little guy with the light bulb a few times. Every time you see him, I learned something. Whether you do is up to you. So the industry standard that runs behind these machines is a thing called geometric code, or G-code, which if you own a 3D printer and you've gone through it and you've looked and you've got this text file out of your slicer that you're going to put into the printer, you get these lines, and most of them start with the letter G, because G-code. So there's a few of them that are very important to us. G01, draw a straight line from point A to point B at some speed. G02 and G03 are draw an arc either clockwise or anti-clockwise. And G00 is turn off anything that was drawing and just move as fast as you can to this location. With those commands, you can theoretically draw any shape. Now, because we're doing lasers, we only have to care about X and Y. If you're doing printing or CNC machines, then you care about Z and you add another degree of freedom. And our mathematicians will tell you that it's hard. There's a reason I chose lasers. There's also another set of commands which your machines care about, and those are the M commands or machine commands. And those are things like on, off. So 3 and 5 in this case, laser on, laser off. Important if you've got a CNC machine where you're changing router bits all the time. There's a list as long as my arm, and I did not go into them. All right, we've got the basics. Let's go into my attempt at a plan. I was planning a procrastination joke for this slide. I never really got to it, so we're doing deadline-driven development instead. Okay, you guys are a lot kinder than Joburg. I don't think they noticed. All right, deadline-driven development. I understand that these are fighting words in software. and that we don't like deadlines. We feel like they're restrictive and they're bad planning and they're anti-agile, you know. But deadlines also mean that we kind of finish things. Because I don't know about you, but my ADHD needs a little bit of stimulus on you've got to actually do the thing. In my case, that was I submitted a talk to a conference. I was like, cool, I'm going to start the project. Also, I don't think they're going to accept it, so that'll give me an escape route. Then I don't have to do it. And then in January, I got an email from Robert saying, we like this talk. Don't you want to do it? Okay. So I had to build a plan. I am in software. I do use Jira for my own personal projects. I like moving things from A to B because I can see it be done. I had a bunch of milestones. I had 6 months to do the project. How hard can it be? The other thing with all of this is I am the designer, I am the developer, and also kind of the stakeholder. I get to make my own choices about scope, about all of those things. The one thing that you can't do for this conference is move the deadline. You get responses like, who needs slides? And you don't have to talk, but then you might have to dance. I'm not a good dancer, so we're talking. I had a set of milestones in my plan. So the physical aspects of the device, which I kind of vaguely knew where I was going. Electromechanical, meaning they were wires and integrated circuit boards, and I hadn't touched circuit theory since high school. You know, it was going to be great. And software. I was the most confident about the software because I do that all the time. Then we had things I don't know anything about. Motors. I spent a lot of time on motors. I did eventually maybe work most of it out. Power, because motors need power, and I wasn't sure how that was going to work. And then lasers, and I cheated on this one by buying a module that was fully contained and had everything, and I just had to plug it in correctly. Foreshadowing. All right. Prototyping and debugging, because it's an infinite loop and you're never really done in a project. It's the same between DIY and software. There's a lot of overlap. It's terrifying. This is where it began. I was going to get more into CAD. I'm not good at high learning curves, so I started on a whiteboard. I drew some pictures. I got some ideas. I also then didn't erase things before I kept debugging other things. And so it's, yeah, that's how I think about things. Then I got into CAD because every corner on those drawings needed a physical thing to hold pieces in place. I spent many days being very irritated with FreeCAD because it chains things in unexpected ways. But there is something absolutely wonderful about going from that, which is just a rendering, to that, which is some of my first prototypes coming out, getting things screwed in. I did after this go and buy screws of the right length. You know, you learn as you go. One of my less favorite aspects of this project is if you're in this maker space, you know that certain items go out of stock all the time. One of those things is very nice stainless steel shafts. And so everywhere that I buy my weird bits and bobs was out of stock of 8mm stainless steel. So I went to Builder's Warehouse and I bought mild steel. And that's what that front one is there, that black, nasty looking one that does not go into a linear bearing nicely and does not move at all. So I made a jig and started sanding for several days. My hands were sore, yes. However, it worked. It solved the problem. I got to keep moving forward. Spoilers, I did eventually find the stock that I needed. So prototype, mild steel, final version that's up there, very nice chromed steel, and every time I try to move something, I just yeet something off the end of a rail because there's no friction whatsoever. All right, this is the bit where I go, is it working? There we go. Motors. Yeah, that's my brain every time I thought about motors. I wrote a blog post about it, which the comment was, it's like a physics lecture that I didn't really want to be in. Thank you, Duncan. Um, and the problem here is that's a 30 Rand hobby motor, super cheap, very easy to use, very well documented, not very powerful. But I spent days going back to my good old mechanics lectures on torque and how much power does this use and how strong is this motor. And I came to the possibly erroneous conclusion that this thing would be fine. However, while that's going on, we're also learning stuff on the printer. Because PLA, which is the basic easy plastic that you use with your printer, also warps at about 30 degrees. And we live in South Africa, and in summer, that's just, the middle of the day. I can think of very few things worse than having to reprint my laser engraver just so that I can use it. So I investigated other types of plastic. And I moved on to ABS, which is a type of nylon and is rated for 100 degrees. If we get there, we've got other problems. I'm not going to be worried about laser. I was quite proud of myself for only requiring 4 attempts to get a full benchy, because this stuff is notoriously difficult. You have to slow everything down, change the temperatures. But then, we got going, but it wouldn't be a printing project without one of these. This is not what your spool is supposed to look like. Those knots just stop the print, and the printer doesn't know because it hasn't broken. It just can't get any more filament. So, part of life. Eventually, I have a set of parts. I can put all the wires together. It's all working. It's lovely and in a breadboard because I know nothing is final until it all works. I've been in software long enough to know that I should test things. And I started, really putting the pieces together, got a board so that I could keep everything stable, and started putting those bands on. At this point, the tension in those bands is literally just me going, how tight can I hold this and screw something in at the same time? It's pretty good. It's not great. But the real test was, can the controller take a command and make this thing move? The sharp-eyed among you will see the tiny little original motors are in the corners there. So the answer is no, it can't. And I'm back on the hunt for tiny devices. Now, I know some people's fingers are large, mine are not. Those are tiny devices. The motor, though, that's a nice one. It's nice and strong, but it uses an entirely different device. And what I learned here was about a thing called a potentiometer, which is a device that you turn and it changes the voltage and the current, and it does all sorts of awesome things. There are 2 documented ways of setting your potentiometer. Option 1, plug the motor in and move the dial until the motor runs smoothly. Yeah. Option 2, plug your values that you know from the spec sheet into this very, very simple, like not even first year physics circuit theory equation, and then set it with a multimeter according to the voltage that that equation spits out. One of these works, one of them is frustrating. I'm sure you can guess which is which. By the time I'd done the maths and been annoyed with myself for thinking that the maths was not supposed to be the easy route, I finally had a thing that could move. I was very pleased with this. And even better, it goes in both directions, which those tiny little hobby motors, even though they claim to be bipolar, they're not. They only go forwards or backwards, depending on how you've got them set. So we're back to the drawing board. We're redesigning parts to work with the bigger motors. We're redoing the wiring. And we're also learning that ABS is, in fact, more strong than I hoped. I have some magnets in there to hold the rails in place. And then I redesigned the part with the magnets in it, and I didn't want to buy more magnets. So I spent some time with a craft knife hacking up some bits of plastic, and at least I'm confident in the print. It was irritating. So we get to this point. I have been told that I have friends with crimping pliers, but I didn't have those. So I used a pair of needle nose pliers, turned my wires from a terrible rat's nest into something vaguely kind of neat. I only burned myself once on the soldering iron. I was quite proud of that. And I finally had all of these pieces coming together. My assistant wasn't so sure. His problem with this may have been the fact that I built my project in his favorite spot to sit. However, he did keep an eye on everything. All right. I've got most of the physical aspects, most of the hardware aspects. You've seen some things kind of coming together. You've seen I've been testing stuff from a Raspberry Pi. Now I need to go into what does it take to decode G-code into movement? Step 1. I need to run the GPIO pins on the Raspberry Pi. General purpose input-output pins. There are two libraries that are rarely looked at. There's the default library, rpi.gpio. You don't have to install anything, it just works. It's great for testing. It's also got really weird documentation, as in hard to find and hard to read. That documentation says it's incomplete and not good for time-sensitive applications. So I went with something else. PyGPIO, which is written in C and then has libraries in all of the various languages that you could possibly want, is complete beyond what I could possibly need for this project, has a daemon that runs on the Pi, which means you can theoretically control this entire system remotely, which I haven't done, but it is quite useful. So if you wanted to run this thing on a Pi Pico or something like that, you could get quite far with that. So it felt like a better option. Then I had to go back to high school and do some trigonometry. That was okay for drawing triangles and straight lines. That's easy trig. I had some AI help at this point, and mostly I got to tell the AI, no, you don't know what you're doing. Because it couldn't figure out where the quadrants were and what's forwards and what's backwards and what's negative, and I had to do most of it. And then I tried to ask the AI to do circles, and it got it wrong so many times that instead I outsourced it to my mother, who does enjoy maths problems and thought that this was fun. And so I gave it to her on a long weekend, and a few days later I got a Python script via Signal. It's a great way of sending scripts, which I incorporated, and it worked a lot better than anything the AI did. So, eventually we get this thing working, and we've got some video of it. We'll see a much better version of this, but it does straight lines. And then we get this. So, there are two really interesting things on this slide. The first is that acronym. Problem exists between keyboard and chair. These are the very hard ones to debug because, well, nobody wants to admit that they're the problem. Maybe Taylor Swift does. The other one, for those of you who know microelectronics, you've already spotted it and you're already kind of cringing at how obvious this is. So your red cable carries voltage, your black cable is the ground, and your yellow cable is your control signal. Printed on that board is what should go into each point. PWM is not power. It's modulation. That's your control signal. VCC is not whatever I thought it was. It's voltage, current, those things. So they're backwards. I am very lucky that this is a diode laser, and that when you put things into diodes the wrong way around, all that they do is they say no. So no magic smoke came out, but also I was, giving the control module a constant 12-volt supply and the power module a very inconsistent 3-volt supply. Well, I wonder why this didn't work. It took me days to debug this. Yeah. But eventually, I was incredibly happy because I made it work. Loose connections aside, I did eventually fix those. The light goes on, I give it a command, and we should see in a moment. Ah, yes, video me figures out that the light's gone on. And I could actually see things are coming together. It's a very bright blue, by the way. I was wearing safety glasses every time I tried to turn on the laser, and so I did not damage my eyesight. That's 450 nanometers, very powerful, not good for your eyes. The reason it's unplugged is not just the smoke alarms, it's also all of your vision. But we had this thing working. Now, I need to turn pictures into G-code, which I can feed into the machine. But this is also last weekend. Well, a little bit less recent than that, but I did not have time. So you go into vector graphics, you need SVG files, scalable vector graphics, which are then able to be converted into paths, and then you need software which can do that. You get into the nice thing called Inkscape, which technically has built-in G-code extensions. They are complicated, undocumented, very strange. I couldn't make them work. I couldn't even find a tutorial. I don't know what happened. Normally open source stuff is good. Which comes to open source solutions, somebody wrote SVG to G code. It's there on GitHub. It's fantastic. Somebody else even turned it into an Inkscape extension. So you copy the library into the appropriate folder, and now you can just do an export. Wonderful. I didn't have to do it myself. I would have. I really did run out of time for it because I needed to be able to do this. That set of axes has a kind of a problem with those zeros in that they are overlaid on one another. That's not what they were supposed to look like. It turns out that for my G00, which was move very fast with the laser turned off, I had allowed the AI to set the value. It was trying to go at something like 3,000 millimeters per second, which at that point, the motor just says no and does nothing because it's getting signals so fast that it just doesn't know how to process them. When you turn that down by a factor of 10, you get something that looks maybe like a 6-year-old drew it with a ruler, but hey, it's recognizable. So I moved on to safety and sorting out my wires and turning my Pi upside down and got it working. And so at this point, it's safe. You no longer need glasses. It's diffused light through a different color. And I also knew I couldn't do a full-on live demo because it did produce more smoke than I expected. And so that's as far as we got in Joburg because that puff of smoke, the thing finished, and you can see the final result actually looks pretty cool. Not good enough to cut up and bring as swag, but still pretty cool. So that would be the end of the talk, but we're going to try and do some stuff live. In the meantime, the one QR code is for the GitHub where the code lives, because you could do that. The other one is for the talk rating. I think I remembered to change it to Cape Town. I'm going to unplug that in about 30 seconds, so move fast. And then we're going to plug the Pi and the laser into the big screen and see if we can make things move. All right. All right, most of the phones are down. We're going to move that. And we're going to do this. This, by the way, is one of the fun parts of having it all running off a Raspberry Pi. All right. I don't move anything, it might stay. Very good. Let's find the right, no. There we go. Okay, so some people say they don't do front-end development, and then they give you a funny little thing that they made that looks meh, but it's a front end. I say I don't do front-end development, and I say I found the Python command library. It looks like that, and that is the entire user interface for this device. So I hope you like a command line. And now, so we should have here, if I say that, move in the x direction 100 millimeters at a speed of 100 millimeters per second, positive, because it's currently somewhere at 0, we should be able to go. Oh no. You know what I forgot? Power. I did not turn on the motors. Okay, we'll try that again. At least the pi was on. There we go. All right, and now we're going to tell it, you're at home. That's a good place to make home. I can grab some of my really random details, such as what pin each thing is assigned to. That one, it's just reading a config file, honestly, but it was good for debugging. And we can say draw file, let's see, DC small. I hope that's right. Nope. Okay, we'll go with the file that I know what to call it. So that's a G-code file. You can hear it shaking the stage. Stepper motors are going step, 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 step. And because it's a big wooden box, it's literally acting like a speaker, like a resonance chamber. It's very loud. But it does what it says. So there we go. We managed to fit a live demo in. Thank you all for coming and enjoy the rest of DevConf. Don't forget to rate.